Okay, I'm going to walk you through DNA replication. So we're going to take our DNA strand that we need to build. So let's say this is our DNA strand, and we want to make a copy of it. So our first issue that we have is that we need a way to split the DNA open. And so we've got a very unique enzyme called helicase. I'm going to draw it right here. Our little triangle. It's going to grab onto the DNA. It's called helicase. And it's going to split the DNA open. Okay, so we're going to go from this piece, and we're going to split it open. As the helicase runs along, it's going to split open the DNA like this. Okay, so here's our DNA. I'm just going to draw little pieces that get split open. Okay, and this would indicate that our helicase is driving along in this direction. And it could split apart in either direction. In fact, it does, but we're just going to follow it in one direction for now. Okay, so let's now record our 5' and 3'. So let's say this top strand is running 5' to 3'. Let me make sure I follow it along. And then this one is running 3' to 5'. Okay, so that's our problem number one. We've now split it open. Our problem number two is that DNA polymerase can't start a strand. It can only add to a pre-existing strand. And so, but we do have an enzyme. We remember from transcription that RNA polymerase can just jump right in there and start copying the DNA. And so we can use an RNA polymerase. We're going to use a very specific one that we call primase. You can draw my little enzyme here. This is primase. It's an RNA polymerase, and it can start the DNA. Now, we only build DNA in one direction, from 5 to 3, just like we read it. So I want you to look at this bottom strand and top strand and decide which direction it's going to be building on the top strand and the bottom strand if it builds from 5 to 3. So pause for just a second and think about that. Okay, so if you're looking at this, remember this bottom strand here is running 3 to 5 and the top strand is running 5 to 3. So the new DNA that we're going to build on the other side will be running 5 to 3 and 3 to 5. So it's going to build from left to right on the bottom strand and from right to left on the top strand. But to get started, as I said, we need to have primase come in and build a little primer. And so that's what's going to happen here. It's going to start, it's going to build a little RNA primer. So this is a primer, and it's made out of RNA. Okay, and it's going to start. Once it gets started, then DNA polymerase, our kind of clunky enzyme, is like, oh, I understand what's going on, and it can start moving along that strand. This is DNA polymerase. So it can keep adding to an existing strand, it just can't start it. So DNA polymerase is going to book it along, and it's going to be adding DNA along that strand. So I'll draw that in here as it goes. Copying along, and it's just going to follow the helicase as the helicase opens the strand. Now let's look at the other side. The other side's going to have to go in the other direction. So simply the primer's just going to lay it down, and then the DNA polymerase is going to grab on and continue in that direction. But you notice as the helicase opens more and more, it's just going to have to keep restarting again and again from that side. So it just goes a little slower on the one side versus the other side. Now there is one thing I want to show you towards the end of the DNA strand, so I'm just going to go to the next slide here, and we'll open up just this end so I can show you something. Oh, but before I do, I need to mention one thing. As this DNA polymerase is moving along the strand, it'll run into the next place where it's been opened up, and there'll be a DNA polymerase coming from this end that will just replace those primers. So we don't end up with little pieces of RNA in our DNA, because the DNA polymerase coming from before will go ahead and finish that off and replace those primers. But at the end, we have an issue. Okay, so we've just followed the helicase to the very end of the chromosome. So just split up the whole chromosome and it falls off. And so on the bottom strand, we've got the DNA polymerase that's just cooking along down the strand. So it's just going to finish the copy all the way down. No problem, hits the end, falls off. But on the other side, we built a primer first, and then the DNA polymerase grabbed on and headed in this direction, right? Which is all fine and dandy. However, we have a problem at this very end because there's no DNA polymerase that's going to be coming from this side to replace this primer, because this is the end, and the DNA polymerase, remember, can't move the other direction. And so what we end up with is this piece of primer that just disappears, and you end up with this single-stranded piece of DNA right here on the 3' end, which eventually just falls off, which is why your DNA gets shorter each time you do mitosis and replicate the DNA. And remember, we talked about we've got protection at the end of the chromosomes in the form of telomeres that help us not lose junk. But that's why we lose a little bit every time we replicate. It's because the DNA polymerase molecule just cannot start a DNA molecule. Pretty crazy, huh? And that's what causes you to age.